Okay, today's lesson is going to be on congruence in right triangles and congruence in overlapping triangles. And the reason I'm putting these two together is there's not a lot of concepts. It's just repeating some of the concepts that we have already learned in the previous lessons. So here we go with today's lessons. First thing I'm going to do is I'm going to quickly go through the reviews and then for each for 4-6, and then I'll do 4-7 when we get to it. But the review, once you go out and fill them out, segments that are congruent have the same length. That is true. Polygons that are congruent have the same shape but are not always the same size. That is false. And incongruent figures corresponding angles have the same measure. That is true. So now I'm just going to quickly go through answers here. 4 is, 5 is 2, 6 is greater than. 7, we're going to cross out segment BC, and in 8, we're going to circle AC, segment HI, and segment ED. So let's go ahead and get on with the lesson for 4-6, congruence in right triangles. What it says there at the top of your slide that you can't read and you can read on your paper, you can prove that two triangles are congruent without having to show that all corresponding parts are congruent. So in this lesson, we're going to find out we can prove that right triangles are congruent by using one pair of right angles, a pair of hypotenuses, and a pair of legs. So the hypotenuse leg theorem is like this. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. We know that triangle PQR and triangle XYZ are right triangles because of a little right triangle symbol. We know their hypotenuses are congruent and they have one leg congruent that's the same leg, so that we can say triangle PQR is congruent to triangle XYZ. So to use the hypotenuse leg theorem, the triangles must meet three conditions. So we're going to complete each sentence with the word right or congruent. There are two right triangles. The triangles have congruent hypotenuses and congruent legs. All right. So let's continue on looking at problem 10. How do the triangles, look at the take note above, how do the triangles in the take note meet the first condition in exercise 9? So basically all we're saying here is that PQR and XYZ are right triangles, or right angles. Angle PQR and angle XYZ are right angles, and therefore the triangles are right triangles. How do the triangles in the take note meet the second condition? So how are they have congruent hypotenuses? Well, the obvious answer is the hypotenuses PR and XZ are marked congruent on the diagram. And hypotenuses is spelled wrong there. It should have an S on it. But they are marked congruent on the diagram. And also, likewise, the legs are marked congruent on the diagram. So, since they're marked congruent, they meet all the conditions listed there. Continuing on, using the hypotenuse leg theorem. Given that angle PRS and RPQ are right angles, and that segment SP is congruent to segment QR, we want to prove that triangle PRS is congruent to triangle RPQ. So if we look at it, we have the hypotenuses are congruent and the right angles, they both are right triangles. They have right angles, which are always congruent. So it's kind of obvious we need to find one leg to be congruent. And since they share a side, which is a leg to each triangle, we're going to use the reflection property to prove this. So angle PRS and RPQ are right angles. So triangle PRS and RPQ are right triangles. We're given that SP is congruent to QR. And by the reflexive property of congruence, PR is congruent to itself, or RP. So we put all those things together. We have a hypotenuse congruent, a leg congruent, and they're right triangles. So by the HL theorem, triangle PRS is congruent to triangle RPQ. So that's how we use the theorem. Now we're going to use it to write a proof. All right, given that segment CD is congruent to segment EA, and AD is perpendicular bisector of CE, which means that AB is congruent to BD, we're going to prove that CBD is congruent to triangle EBA. So first thing we're going to do is circle what you know because AD is perpendicular bisector of CE. So triangles CBD and EBA are right angles. And in addition, we know that B is the midpoint of segment CE. So those being perpendicular bisectors create two things that we need to use the HL theorem. So we're going to circle the congruent legs. We know that CB is going to be congruent to EB. In addition, we also know that AB is going to be congruent, or which one's the bisector? Okay, so we know that CB is congruent to EB. All right, I had stated that wrong. So write the hypotenuse of each triangle. The hypotenuse of CBD is CD, and the hypotenuse of EBA is EA. So let's quickly go through this proof. CD is congruent to EA, because that's given. Angle CBD and angle AEBA are right angles. That's the definition of a perpendicular bisector. And so it's triangles CBD and triangle EBA are right triangles, and that's the definition of a right triangle. So segment CB is congruent to segment EB. Again, that's definition of perpendicular bisector. So we finally know, because we have a hypotenuse and a leg, we can say that triangle CBD is congruent to triangle EBA. So let's look at our lesson check. I told you it's a quick lesson. Your classmate says there is not enough information to determine whether the two triangles at right are congruent. Is your classmate correct? There are 3 right angles. That is false. There are only 2 right angles shown in the picture. There are 2 right triangles. That's true, because the right angles are in the separate triangles, so there are 2 right triangles. There are 2 congruent hypotenuses. That's true, because it's given. There are no congruent legs. That is false, because they share a leg. You need to use the reflexive property of congruence. That is true. LJ is congruent to LJ is given. That is false, but that's how we're going to prove that the triangles are congruent. So continuing on, do you always need 3 congruent corresponding parts to prove triangles congruent? The answer to that is no, because if you have right triangles, you only need 2 parts. So no, you usually need 3 congruent corresponding parts, but not if the triangles are right triangles. And finally, is your classmate correct? No, since the hypotenuse and the shared leg of one right triangle are congruent to the hypotenuse and shared leg of another right triangle, the triangles are congruent by the HL theorem. So basically, the lesson that we just learned 4.6 is simple. If you have 2 right triangles, their hypotenuses are congruent, and one of the legs, shared pair of legs, is congruent, then the triangles are congruent. Now let's look at corresponding congruence and overlapping triangles. Quickly go through the review here to give you the correct answers. Make sure you have them right. Circle the common side of triangle ABC and ADC. The common side would be AC. Circle the common side of XWZ and YWZ. The common side would be WZ. And circle the common side of RST and RPT. The common side would be RT. Overlapping means that things share parts in common. So we're going to look at a bunch of triangles that share things in common. If you look at the problem, circle the common regions of the overlapping figures in the diagram at right. If we look at triangle FGD and triangle CBE, they share in common triangle EHD. Likewise, triangle BEC and triangle HED share in common triangle HED. Triangle ACF and triangle ABG share in common triangle ABG. And finally, triangle ACF and triangle GBH share in common triangle GBH. So let's continue on looking at overlapping triangles. First, we have to identify common parts. So in the first part, we're going to separate and redraw triangle ABD and triangle DCA. So here's ABD, which is the bottom left triangle, and then DCA is part of that triangle ACD. So when we drew those two triangles over, we drew segment AD twice. So the common side of those two triangles is segment AD. Now we can use common parts to prove triangles or set parts of triangles are congruent. So I'm saying that triangle ACD, this is given, is congruent to triangle BDC. I want to prove that CE is congruent to DE. So let's look at what we know. We know that triangle ACD is congruent to BDC, and triangle ACD and BDC are overlapping triangles. We need to find common parts of triangle ACD and triangle BDC. So we want to show that ACE is congruent to BED, and then we can use corresponding parts of congruent triangles are congruent to prove that CE is congruent to DE. So here we go. First thing we're going to do is triangle ACD is congruent to triangle BDC. That's given. So now we can use CPCTC to say that segment AC is congruent to segment BD. We know that angle A is congruent to angle B by corresponding parts of congruent triangles are congruent. Angle ACEC is congruent to angle BED by the vertical angle theorem, and therefore we can say that triangle AEC is congruent to triangle BED by angle, angle, side. We have two angles and a side, a non-included side, so we can say that the two triangles are congruent. And now by CPCTC, we can say that segment CE is congruent to segment DE. We'll go through some of these proofs because it's just, you have to look at it and make sure you look at the different parts and make sure you're going, if you draw along as you write down these statements or follow along these statements, it makes it a little bit easier to see this proof develop. So how could you use the converse of the isosceles triangle theorem to prove that CE is congruent to DE? Well, angles BCD and angle ADC are corresponding parts of congruent triangles. So angle BCD is congruent to angle ADC. CE is opposite angle ADC, and DE is opposite angle ACD. So CE is congruent to DE by the converse of the isosceles triangle theorem. So like I said, there's more than one way to do a proof, and in this particular case, there are two ways to prove that segment CE is congruent to segment DE. Now let's look at how we use two pairs of triangles. We are given that PS is congruent to RS, and angle PSQ is congruent to angle RSQ. And we want to prove that triangle QPT is congruent to triangle QRT. So first we can say PS is congruent to RS, that's given, and the angle PSQ is congruent to angle RSQ, that's given. I know that ST is congruent to ST and QS is congruent to QS by the reflexive property of congruence. So if I put these things together by side, angle, side, I get that triangle PST is congruent to triangle RST, and triangle QPS is congruent to triangle QRS. Now, how can I say that PT is congruent to RT? Well, corresponding parts of congruent triangles are congruent. In addition, I can say that PQ is congruent to RQ because corresponding parts of congruent triangles are congruent. Finally, the last one, QT is congruent to QT by the reflexive property. So since I have three sides congruent, by side, 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 I can prove that triangle QPT is congruent to triangle QRT. Finally, let's look at separating overlapping triangles. Given that triangle CAD is congruent to angle EAD, that's those little bitty angles there at the end, and that angle C is congruent to angle E, we want to prove that segment BD is congruent to segment FD. So first thing we have to identify are the vertical angles that we have in the drawing. And if we look at the drawing closely, we can see that angle BDC and angle FDE are vertical angles. Now we want to mark the angles that we know are congruent in each pair of separated triangles below. So I'm going to have to get my pen out here real quick. All right, so I know that A is congruent to A, and I know that D is congruent to D. In the next set of drawings, I know that A is congruent to A, and C is congruent to E. In the next set of drawings, all I know is C is congruent to E. And then last but not least, I know that C is congruent to E. Okay, so which triangles are congruent by angle, side, angle? Well, obviously, ADC is congruent, so ADC is congruent to ADE. CAD is congruent to EAD. And angle C is congruent to angle E, and AD is congruent to angle D. AD, common side, they share a common side. So angle, so I got angle CAD, angle EAD, this angle right here, angle C and angle, excuse me, I marked the wrong note, angle C and angle E, angle CAD and angle EAD, and then this side that they share, so that's angle, angle, side. Let's continue on looking at this. Which triangles are congruent by ASA? Triangle BDC is congruent to triangle FDE by ASA. Angle BDC and angle FDE are vertical angles and congruent. Segment CD is congruent to segment ED since they are corresponding parts of those two triangles, and angle C is congruent to angle E. So how can you prove that segment BD is congruent to FD? They are corresponding parts of congruent triangles BDC and FDE, which we've already proven to be congruent by ASA, so they are congruent. So let's quickly check our lesson. Is the hypotenuse, so it's in the figure right, which pair of triangles could you prove congruent first in order to prove triangle ACD is congruent to triangle CAB? So it's ACD and CAB. The hypotenuse of ACD congruent to the hypotenuse of CAB. Is the hypotenuse congruent? So we got A, C, D, and CAB. So yes, their hypotenuses are congruent, and we can use the segment addition postulate to prove that, because this plus this is congruent to this plus this, since all those things are congruent. So what else do we need to prove the right triangles are congruent using the hypotenuse leg theorem? We need to know that we need to show that AD is congruent to CB, or AB is congruent to CD. All right, it's obvious what we have here is a rectangle, so all our angles are 90 degrees, and we have nothing but a bunch of right triangles there. So we can use the vertical angles theorem and side angle side to show that ABE is congruent to CDE, or AED is congruent to CEB. But either way, we can prove the we can prove those triangles congruent using side angle side. Had a brain just died there for a second. All right, so here we go. That's the end of the lesson. I'll see you in class on Thursday, and we have Thursday and Friday to work on these two chapters. Have a good evening. See you tomorrow.